We start this chapter by talking about plane mirrors. So this blue slab, this is the plane mirror, and the light falls on the mirror. So this is the light coming, it falls on the mirror. So this red line is the normal to the mirror. Normal means it makes an angle of 90 degrees with the mirror. So this is the normal to the mirror. Now the angle of incidence is the angle between the incident ray and the normal. So say this angle is theta. Now once the light falls, so the light is falling right here, it gets reflected in this direction. Now the angle of reflection is again theta. Again this angle is measured from the red line to this black line. So the ray comes in this direction, it falls on the mirror and it gets reflected in this direction. So angle of incidence is the angle between the incident ray and the normal. So this is the normal. And the angle of reflection is the angle between the normal, that is this red line, and this reflected ray. Now we talk about spherical mirrors. Now there are two kinds of spherical mirrors we will talk about. One is concave and another is convex. So first let us focus on the concave mirror. So say you have a parallel beam of light. So all this is a beam of light. So this light is incident on the mirror. So this is the reflecting surface of the mirror. So this surface, this side reflects. So the light falls on the mirror and then the light gets concentrated towards a point called F. This F is the focus. So again, a parallel beam of light falls on the mirror. So this is the beam of light, we are traveling through it, then it gets reflected like this and it falls on the focus. Then you can focus on the second beam again. So this beam of light goes like this, falls on the mirror and then gets reflected. Similarly you can focus on this beam of light goes like this, falls on the mirror and then gets reflected like this. So you end up falling on the focus. Now we talk about convex mirrors. So again you have a parallel beam of light. So the parallel beam of light, so these are the light rays which are coming. So these are all the light rays which are coming. So once the light falls on the mirror, so this side is the reflecting surface. So this is the reflecting surface. So once this falls on the mirror, it gets reflected like this. So notice that light is now diverging. Here the light was converging to the focus. Here the light is diverging. Similarly you can take this ray which falls directly on the surface which is perpendicular. So if you take a plane here, this is kind of perpendicular, so this gets reflected back. So again a ray of light which comes like this, falls on the surface, it diverges like this. Now if you trace it back, so if you go in the opposite direction of this, so if I try to go in the backward direction of this ray, we reach a point called the focus. So when you put a parallel beam of light on a convex mirror, this parallel beam of light diverges, but it appears to be diverging from a point F, and this point F is called the focus. Now let us focus on some notation. So the notation is that P is the pole or the geometric center of the spherical mirror. So let us just mark P right now. So for the convex mirror, this P is right here. For the concave mirror, this P is right here. So this is the center of the mirror. Now C is the center of curvature. Now center of curvature means that you see these mirrors are curved, that is there is almost a circle here. Yeah, so this mirror is nothing but part of a circle. So you can think of it, this mirror, as a part of a circle. So this circle has a center. So this center is called C. So this C is the center of curvature. Similarly, this concave mirror is part of a circle. Yeah, and the center of the circle is this point C, and this C is what is called as center of curvature. Now we talk about principal focus. So principal focus we have already shown before, this point F. On a convex mirror, it seems that the rays are diverging from F. In a concave mirror, it seems that the rays are converging to F. Now the line joining C and P is called the principal axis. So line joining C and P is called the principal axis, and the distance between them is the radius of curvature. So the line joining C and P, so we have drawn this big line between C and P, this is called the principal axis here. Again, the line joining C and P, this is called the principal axis, and the distance between C and P is called the radius of curvature. So let us draw the distance between C and P. So this distance between C and point P, this is called the radius of curvature. Similarly, here we can say distance between P and the C is right here. This is also radius of curvature. The distance between F and P is called the focal length. So notice the focal length right here, the distance between F and P. Again here, the distance between F and P is called the focal length. Now to do the problems or to understand the physics behind these mirrors, we have to give some conventions so as to measure the distance of the object kept from the mirror. And for this purpose, we need sign convention. The sign convention follows the Cartesian convention. So this follows the Cartesian convention. So again, to remind you, the Cartesian convention is just the standard plane with x and y axis. So in the Cartesian convention, you have the x-axis like this and y-axis like this. So this side is positive for x-axis and this side is positive for y-axis. So we try to follow the same convention here, but here the light determines which direction should be positive. So to start with, distances are measured from the pole of the mirror. So from this point we are going to measure the distance. So they are taken as positive in the direction of incident light. So say the direction of incident light is this, the light is coming in this direction. So the distance is positive in the direction of light. So the light is coming like this, so the distance is positive in this direction, just like positive x-axis. And if we are going to measure distance from here to some point here, then the distance towards the left is negative, because now this distance, so say distance from P to point B, so this distance would be negative because we are going to start measuring from P and we are going in the opposite direction. Whereas distance from say P to point D here, this is positive. P to B is negative, P to D is positive. So again, distance is taken as positive in the direction of the incident light and negative against the incident light. And the height measured upward is taken as positive. So if you measure the height upward from the principal axis, so again this is the principal axis, so this is the principal axis, so height measured upward from here is positive and the height measured downward from the principal axis is negative. So height downwards is negative and height upward from the principal axis is positive.